Hi, so in this video we're going to talk about how firewall evasion basically works. So this is a theoretical video where I'm going to talk about different kind of techniques you can go ahead and research further in order to understand. Now I will make this clear that there are different ways you can do firewall evasion by, for example, using Metasploit. It got different kind of ways to do that. You can also do it yourself. There are different ways you can do it yourself. You can do it by coding stuff in Python. You can do it by obfuscating your traffic or by hiding your traffic in other protocols and so on. But let's get started with it. I have 10 different points to point out on how you could essentially do firewall evasion. Let's first talk about why this video exists and why I decided to create this video. So I feel it's important for you as an ethical hacker, just an IT security interest, that guy, that to understand how firewalls actually going to detect the traffic coming through it. So you're going to imagine that you are the hacker down here below, and you will send some packages. Let me just craft a packet. This is a packet, and the packet today is going to be green. That's the way it is. So you're going to take this package, and it will travel from the attacker to the firewall. The very first thing going to happen is the firewall will evaluate the packet, look at it by different kind of rules that are set up in the firewall, and depending on how advanced the actual firewall is, it can also have some machine learning stuff going on inside of it, deep learning stuff attached to it, and so on. Now next step is going to be the IDS, which is going to be the intrusion detection system, and that can be quite different from the firewall, because an intrusion detection system also acts in the similar way as a firewall does. Look at the package, try to determine whether this is a legitimate package, it should be entering our network or not. Basically that's the game we're going to go and talk about. The very first one is called packet fragmentation. Now the thing is, when you're going to go ahead and send this package directly here from the attacker to the firewall, the whole packet itself might be too large, too big, too easy to understand for it, so it's going to be discarded. Now if you can fragment this, let me just create a fragmented package. So let's copy this, and then we can basically fragment it. So now we're going to send the very first part, so that's the first part you send. When you send that, it's going to say, well, it's just a packet. I'm going to go through and boom, inside. And the next packet and so on. And eventually, when all the packets arrive at the same place, they will be connected one more time to be the whole packet. Now, of course, this is difficult to understand. We just think about it, but the general theory behind it is that if you're going to use some software to enforce this kind of rule, you're going to pick the flag called packet fragmentation, for example. That could be one way of doing it. You can also go ahead and do encryption. Now, instead of doing actual fragmentation, you can also take the package and say, well, I know this package is green, but I'm going to encrypt it. So now it will look like green with stripes on. And a packet that is green with stripes on is going to go through the network, with the firewall, and through the IDS. Now, it might even be the need to combine those two, like encrypted, fragmented packets, Now, of course, a packet cannot be striped, but as you probably understand, this is a theoretical video where I talk about what you could do. So you could encrypt your traffic. Basically means that the firewall will have no way of looking at the actual packet if it do some deep packet inspection. Now, the difference between normal inspection on packets and deep packet inspection is that inspection on a packet will usually look at the headers, for example, the receiver, the sender, the port, the service, and stuff like that. Maybe the GET request or the POST request if it's an HTTP packet. Now, the deep packet inspection, on the other hand, will look at the actual data as well. Basically, that's the point of it. If you got this deep packet inspection or DPI going on, usually that lies with the IDS. Now, these days things are very advanced, so it can basically be any piece of software more or less. You can also use something called tunneling. This is a specific technique. It basically means you're gonna send data inside another type of traffic. So it could be that you have another type of traffic. Let's assume this is another type of traffic, and this is called the orange kind of traffic. Now, in a way to get your green packet through, we're going to take this green packet and make it fit inside the orange packet. So we're going to send the orange packet, which is the orange kind of traffic, through the firewall and say, hey, that's the orange kind of traffic. We're going to let that through and fit inside the network. Now, in theory, that would be something like, for example, sneaking data inside a DNS protocol, a ping request. If there's some sort of header you can fit, or the void space inside the protocol that's not used, in some way sneak data through with the HTTP protocol, and so on. Now, how would that be useful? Let me just talk about this for a second. So let's assume for just a sec that on the internal network we will have an Apache web server that's going to intercept our HTTP packet. For now on, the orange size, the orange packet is the HTTP protocol packet. So it's going to go to that service directly. Now, of course, something would need to intercept this packet in order to read the traffic. That is, of course, the point of it. But it's not really how it works, because if we're going to send in a packet that is tunneled through network, it can have different kind of receivers, it can be different kind of services receiving, it could be on a different port. The firewall might not look at that, so that's where it get kind of advanced. If the packet is to a specific port on the network, to a specific IP address, or to a specific MAC address or something like that, well, the firewall basically would need to know these kind of things in order to deny it access. You can also go ahead and use a proxy server, routing traffic through an intermediary server to mask its origin or content. Well, basically, firewall can look at the packet. So this packet is green, going to come through here and say, no, I don't want that packet in my network because it's coming from a red server. Now, we don't want to get a red server traffic through our network, so we'll block all the traffic. That's a general idea behind blocking. So we could do that by using a standard proxy server, VPN, stuff like that. That's also one of the points. It's using stuff like Tor or VPN, which is actually the last point I'm going to point out, but I'm going to say it right now. So we have covered 5 different kind of packages. Hello cat. Now types. So we're going to take the next 5. Or we can do something called port hopping. Port hopping is basically essentially the act of switching between ports to find an open one that the firewall doesn't block. Now, basically that's very interesting, because if you do that, you have to send some traffic to the firewall and see what it replies back to. That is also a way, but you still need, and this is where you say, but why do these kind of things? Well, if you need to get in the network some way, you have maybe some traffic to direct inside the actual firewall to get, intercepted by something. Well, then there's a way to try and get through. I know we're on a purely theoretical level right now, and we talk about things as they are a bit, up here, and I know you want to get more down, but this is not the video for that. I'm just talking about the actual techniques. I know it's difficult even for me to create this video right now, because how can I actually explain these kind of things? So that is why I use this image and use these kind of different colors. You also go ahead and use something called spoofing. So spoofing basically means that the packet here could be still coming from the red servers, but and we don't want that traffic. But you're gonna change the sender address from a red sender address servers to, let's say, another green kinda, or maybe a purple server, which is basically just some colors I'm mentioning to give them some character. But that kind of server, our firewall say, I would say okay to purple traffic, so it's gonna be fine. It's be sent in and intercepted by the internal network. Obfuscation is another act called hiding the true nature of the data by making it look benign or like legitimate traffic. That's going to be quite difficult, but sometimes when you, for example, have a web server on the internal network, and that web server will intercept with different kind of things you're going to send. Now the firewall, the ideas might even look for different kind of payloads that's not going to be there. It could be payloads that were looking like SQL injection, cross-site scripting, some of the basic things, maybe even detecting kind of brute force attack. How would you mask that? I'm gonna have to think about it now. What is the filter set up on the IDS? what is the static rules in the firewall? Most occasions, these kind of services are made from static rule sets. This basically means a lot of rules have been applied to look at packages, to inspect them, and so on. There are no such a thing as an intelligent, like a human being brain thinking, looking at the package saying, oh, I see that is something wrong. But we're getting close to it by the deep packet inspection. Also, having more than one firewall, also have an IDS, for example, is going to really up your game. Using allowed protocols is another way to do it. So you could manipulate traffic to look like permitted services such as HTTP or DNS, because you would need these kind of protocols in order to actually go to the web. So without going to the web, there's not going to be no internet, and basically that's not going to be the best thing for your employees if they need to go on the internet to do their actual work. So using allowed protocols basically would involve that you would direct the package as the IP address would be. So if you've got some sort of, you can see that right here we have a router, and that router will direct the traffic to whatever area of network it needs to be directed to. So you could mask it as an HTTP protocol, maybe by altering a header or something like that. It would be somewhat the same when you're altering the header of a file to make the file appear like a JPEG file, where it actually just is a normal text file. So that is the same different kind of thought. And I kind of hope you know what I talk about, because the magic header of a file, or the file header, basically gonna, say my file, me, I as a file, I am a JPEG. That's really what the header says. The last one, also the weird one, I guess we call it stealthy connections. That would apply as making slow intermediate connections to avoid triggering security alarms. Now, that is a thing you basically do mostly when you are doing Nmap. So when you are doing Nmap, you are you can control the amount of traffic you're gonna send back and forth. That is also one of the reasons to do non-aggressive Nmap scans. When you're doing stuff like try hack me or hack the box, you just put all flags on and lit up the whole Christmas tree, right? But that's not really how you're gonna do it in real life. If you're gonna go ahead and do a real pen test without upsetting the firewall, without turning all the red lights in the intrusion detection system, you need to do it slow. It would apply as the same act as a brute force attack if the mechanism or the backend behind of it will lock your different kind of login results. Let's say 3 login results per 30 seconds, just an example. Then you have to limit that. So if you don't know it, you will basically find out, and you will have to change your traffic type or amount in order to avoid these kind of logouts. Alright, so different kind of, the list of different ways will be on the screen right now, and it will also be presented again in the start of the video. You can also find it in the description below. Now, I really hope you learned something from this theoretical, advanced evasion technique, how we do that. So the next step would be for you to go ahead and research these kind of things. Now, I put them for you to take and go ahead and research. So depending on if you are an attacker or you are a blue team, a defender like that, you can go ahead and use the same kind of word to search up how to defend or how to attack or how to evade. So defending and evading is kind of the same thing, but done differently depending if you are the attacker or the defender. Alright, so really hope you like this new kind of flavor as a video, and I hope to see you again online on my channel. Have a really nice day, and hope you learned something. Have a nice day.